Welcome to Massey Dialogue. My name is Nathalie Desrosiers, and I'm the principal of Massey College. Massey College is built on indigenous lands, the lands of the Huron-Wendat, the Seneca, and it is the treaty land of the Mississaugas of the Credit. I want to acknowledge the great privilege that we have to continue to do our work here, and today to look into a particularly vexing question, which is open science and pandemic prevention. We're delighted to have with us Dan Werb, who just published a book on the invisible siege, the rise of coronavirus, and the search for a cure. And he will be in conversation with Junior Fellow Georgia Hadjis, and the chair of our governing board, Akwasi Owusu-Bempah, will be moderating. Fascinating issue that I know is at the core of many of our members of our community who are both committed to open science, but at the same time worry about the risk of that open science movement. So without further ado, Akwasi.
Nathalie, thank you very much. Good afternoon, everyone. It is my pleasure to be moderating this panel today. The promise and perils of open science for pandemic prevention, timely to say the least. With us today, again, Dan Werb, Professor Dan Werb. He is an award-winning writer, an epidemiologist, and his works appeared in the New York Times, Salon, Believer magazine, and many other outlets. He is in the faculty at the Dalai Lama School of Public Health at the University of Toronto and the Division of Infectious Diseases and Global Public Health at the University of California, San Diego. He is the author, as Nathalie has just mentioned, most recently of The Invisible Siege, the Rise of Coronaviruses and the Search for a Cure. And he's authored over 100 epidemiological studies investigating the link between the spread of disease and social conditions. I consider Dan a great colleague of mine. Welcome. We have with us today as well Junior Fellow Georgia Hadjis, a third-year PhD candidate in the Faculty of Dentistry and Neuroscience. Studying neuroscience and pain here at the University of Toronto. A junior fellow at Massey College, her work investigates the physiological processes underlying how pain impacts our ability to perform daily tasks, like multitasking and decision-making. She's worked to improve access for women and girls in STEM and co-founded an organization that advocates for and mentors young women of Greek descent to inspire them to pursue academic and career paths in the sciences. Georgia, welcome. And I am Akwasi Owusu-Bempah, Professor of Sociology at the University of Toronto, Senior Fellow at Massey College, and Chair of the college's board. Let's not waste any more time talking about who we are. Let's get into the topic at hand. Dan, the invisible siege, the rise of coronaviruses, and the search for a cure. Now, whatever could have inspired you to write about such a topic? I kid, of course, that is very obvious, but please, for those that haven't had the chance to read your work yet, please tell us about your book.
Sure. So, this book came about as a result of me trying to put some boundaries on my own anxiety around the pandemic when it first started. So, of course, I'm an epidemiologist. I study epidemics, but the pandemic was this life-altering, global-defining event. And early on, I needed to understand how to make sure that my anxiety just didn't sort of spiral out of control like so many people were trying to do. So I went back to this key concept in epidemiology called the epidemic triangle, which posits that epidemics and pandemics arise from a shift in the relationship between three factors: an agent, so a pathogen like a coronavirus, a host like humans, and the environment within which those two, the agent and the host, interact. And so by doing that, I could get a sense of, okay, well, this started somewhere. Let's go back to understand where that shift happened. What happened in the shift between those three components that would have given rise to this pandemic? And from there, I was immersed in the incredible scientific research that has been done over the past 40 odd years on coronaviruses, really done for the most part by a tiny collection of virologists working in what was a scientific backwater for so long. Before SARS in 2002, nobody cared about coronaviruses. There were, you could count the number of coronavirus researchers worldwide. It numbered in the dozens. But after SARS in 2002, which of course Canadians experienced quite dramatically, with Toronto being shut down, and then with the rise of Middle East respiratory syndrome in 2012, just a decade later, another pathogenic coronavirus. There were some astute observers of this phenomenon among this small group of coronavirologists who understood that these were just precursors to something that was yet to come. And that story and the prescience of those scientists, and I think what we'll talk about also is the forces that were pushing back against their attempts at trying to prevent future pandemics, is the seed of this book. And really what I'm trying to do with the book, and what I tried to do was tell this thrilling story of scientific discovery and the forces that scientists have to contend with when they're trying to deal with things like global pandemics.
And those forces were undoubtedly many, and I do want to get into those. They were political, they were scientific, globalization, travel, all of these things have, created an environment that has led to the situation that we're in now. Georgia, I want to turn to you just for a moment. And I will call you an emerging scientist. As an emerging scientist, we had a bit of a discussion prior to this conversation about your takeaways, and I want you to share with our audience what some of those are. What are your main takeaways from the book, and who would you recommend this book to?
Yeah, that's a great question. I think the main takeaways for me were that coronaviruses are not new. They've been around. They've been infecting humans for 1,000 years. And that is enlightening, but also terrifying because, how are we going to move forward with this? One of the also takeaways I got was that no doubt there will be future pandemics and pathogens that are ready to cause pandemics. So we have to be prepared for that. And so I think that this book would be great for emerging scientists like myself, but also for people who might be a little bit hesitant about the technologies of mRNA vaccines and just science overall. I think that this book gives a really good overview of all of that. And as Dan mentioned, how this sort of relieved his anxieties about the pandemic, I wish I had this book earlier because it really resolved a lot of mine. So I would say those are the main takeaways for me. And there is hope, which is great.
Absolutely. Thank you. Science is a wonderful thing. There's no doubt about that. And I think for me, that's something that, came through in your writing very clearly is just how amazing science can be and what we can do as human beings when we put our mind to, tackling something in our midst. Part of what you cover in the book, Dan, are not only the evolution of science, but like various tensions. And when we think about, the development of vaccines for COVID-19, we need to think about the fact that it was a for-profit system that brought us these vaccines really in record time, in a quite astonishing time. There have been billions of doses of COVID-19 vaccines now administered worldwide. And, people are concerned about this for-profit model. Shouldn't it be more open? What does this mean for health equity? We got these vaccines in the timelines that we did. Why would we want to mess with a good thing?
It's a great question. And really, that's the central question at the heart of this debate between open science and the for-profit system that, essentially does the bulk, if not essentially all of the market-driven medical discoveries that we enjoy today. Now, the issue is essentially that, and maybe I'll just describe it in the context of COVID-19, right? We have, as Canadians, benefited greatly from the for-profit system. We have a record number of Canadians who are double vaccinated, triple vaccinated, and we're among the leaders in vaccination. And that's great. But what we've also seen is that in under-resourced settings, in low-income and middle-income countries, the proportion of the populations that are vaccinated are, in the case of low-income countries, it's around 15% of people who have one dose of a vaccine. So that's obviously, we know, not sufficient to protect people from COVID-19, from becoming infected. And that in itself is a moral problem, and it's a defining moral problem. It's a lack of it demonstrates a lack of collective action on the part of humanity, and we should feel bad that people who are in more dire situations than we are do not have access to those vaccines. However, it goes beyond that, because what we've seen over the past 18 months is the evolution of this virus, right? We keep hearing about new variants of concern. First it was Delta, then it was, now we've got Omicron, now we've got Omicron BA2. Like, it just does not stop, right? And there's the joke going around that we're going to run out of Greek alphabet letters before, this pandemic's over, because we're going to have so many variants. Variants emerge in populations that have not yet reached herd immunity, either through natural immunity, naturally acquired immunity, aka getting infected with the virus, or through vaccine-induced immunity. So what we're seeing is this generation of variants and the emergence of variants, which are naturally going to happen as viruses mutate. Some of those mutations are lucky mutations that improve the virus's fitness. And those variants are going to emerge among populations that are not protected. Those variants, in turn, undermine the effectiveness of the vaccines that we have had the privilege of being vaccinated with. So the longer that we have populations that are at risk, the more variants are going to emerge, the more the effectiveness of these vaccines are going to diminish and be reduced among everybody. So it's this strange situation, and these are rare situations in life, where the ethically and morally correct path, which is to ensure that everybody has access to this incredible medical discovery, regardless of how much money they make or where they might live, is also totally in line with the most selfish path, which is that we want to protect ourselves from variants from this virus as it continues. And so we've got the situation where, the for-profit system, yes, it led the development of vaccines, but, actually there's a wrinkle there that I think is important, because in some cases it was really the U.S. National Institutes of Health that was generating a lot of this momentum. But, writ broadly, it was the for-profit system that generated these vaccines. But the people, we do not, the development of these vaccines in and of themselves is just part of the puzzle of medical discoveries. We need to make sure that the entire globe has access, or they won't work for us. And the medical discoveries will become obsolete for everybody.
Wonderful. Thank you for that overview. And I want to ask you a little bit more, directly around open science. But you mentioned just now, and this comes through in the book, there was government involvement, of course, in the development of the companies that led the development of some of the patents. So I'm thinking specifically about Moderna here. And you talk about different federal government in the United States kind of research and granting agencies. Do you want to talk just a little bit, for those who might not be aware, about the involvement of various government agencies, even in whether it be kind of an adjacent role, the development of related companies and the productions of the vaccines?
Yes, absolutely. So in the case of Moderna, it's really interesting. So Moderna, founded by a Canadian from Scarborough, Derek Rossi, who is this incredible he's like a multi-instrumentalist. He can basically do anything in the lab. He founded this company based on this mRNA technology, which is an effective way of programming cells to generate different proteins. So when he founded Moderna in 2010, I spoke with him at length, and I asked him, okay, well, were vaccines on sort of your target? Were you thinking about vaccines as a potential product that you would bring to market? He was blunt. He said, I wasn't thinking about it. Nobody at Moderna was thinking about it. And I asked him the reason, and he said it was a non-viable business model. So vaccines, they despite what we've seen with the incredible capacity of mRNA to be this linchpin of a new vaccine technology, there was no interest on the part of Moderna and from its founder in going into that space because it wasn't, it just wasn't a viable business model. Cut to about 2015 or so, and there was sort of a changing of the guard at Moderna, and some new personnel came in, and they tried to create closer linkages with the U.S. National Institutes of Health. Part of that, of course, was business oriented, because if you have they were a young biotech company at the time, they were only 5 years old. A great way to burnish your credentials is by partnering with the most august research institution in the world, the National Institutes of Health. And so they created this partnership between the NIH and Moderna. And essentially what happened was the NIH saw in Moderna a partner that could potentially develop vaccines and new technologies and could be directed to do so in a way that didn't necessarily prioritize the market first in terms of its immediate priority. And so what this resulted in was a number of sort of vaccine candidates, a number of trial runs on developing vaccines for conditions and against pathogens that weren't going to make anybody any money. Now, interestingly, one of those vaccine candidates was for MERS, the Middle East Respiratory Syndrome. This coronavirus that I mentioned emerged in 2012, moves extremely slowly, is not a very fit virus in terms of infecting people. The number of people who are or have been infected with MERS is really, really low, and it does not threaten to become a pandemic. However, it has up to 50% mortality. So for some people, it's a flip of the coin if you're infected with MERS. Now, the NIH essentially funded Moderna to generate a MERS vaccine candidate, and the NIH helped to sort of shepherd that work forward. And the point here on the NIH's side was that they wanted to start this larger program of developing representative vaccines for the 26 viral families known to infect humans. So they wanted one vaccine that could vaccinate against one member of each of these 26 viral families. The point was basically, let's set up a system, essentially like, an early warning system, an early protection system, so that the next time a virus emerges, we'll at least have something that's kind of similar to it, and we can reprogram. So what happened? Well, we all know what happened. A new coronavirus emerged only a few years later. And one of the reasons that Moderna was able to enter into clinical trials so quickly, and again, those clinical trials were run by the U.S. National Institutes of Health, is because they had already gone through the work of developing a MERS vaccine candidate. Now, what does this have to do with open science? Well, open science is this concept that scientific discoveries should be done for the public good. They should not be tied to a for-profit system. And that means not patenting any of the technologies and discoveries that companies or researchers make. In the case of Moderna, they got kind of halfway, right? So all of this was patented. None of this was made to be open in terms of anybody could just take the recipe for their vaccine and produce it themselves. But they were at least starting to move towards or being kind of nudged towards this notion of developing technologies for the public good through the involvement and kind of the motivation of working with a government entity. So, we talk about the for-profit system bringing us vaccines in record time, but at least in the case of Moderna, if it weren't for publicly funded science, they would have been far behind in terms of developing their vaccine and bringing it to market.
Interesting. Thank you for that overview. And, I think for me, as someone who's in sociology, I actually do a fair bit of work with government, and it certainly helps me not only fund, but kind of propel my work. And I think about Georgia being in faculty of dentistry, and we think about faculties of dentistry and medicine, and, the long history of relationships that they've had with industry, and how those have often been fraught over time, and how we're, often cautious about government and industry funding work because of what it means for the findings and the reliability of those findings, and where bias might emerge. George, I'm going to come and ask you a couple of kind of related questions in a minute, but one of the things that I think that we really need to touch on, and you've mentioned it a few times here, Dan, is around the patents, right? So, are patents the antithesis of open science, or are patents at the heart of open science? Is it enough to remove patents, or do we have to look further down the chain in order to make vaccine access more equitable? Like, what do patents mean in the context of everything that we've been discussing so far, and in what you talk about in the book more generally?
It's a great question, and it's a difficult one. So patents, you register patents with government, and governments essentially control how, there are laws and regulations around patent infringement and things like that, and that's baked into the regulations around drugs and other medical discoveries like vaccines. Patents it's an interesting history lesson here that, in fact, didn't really make it into the book, unfortunately, because I was trying to keep it as compelling for a general audience as possible. But, something shifted in the 80s where there were all of these private companies that were patenting their technologies, their scientific discoveries. And there was a law passed in the States called the Bayh-Dole Act, which by Bob Dole and Evan Bayh, which essentially allowed for universities to start patenting discoveries that their faculty made. This was a really interesting shift, because what it did was it was trying to kind of even the playing field between academia and publicly funded research and for-profit research. But what it did was, unfortunately, kind of constrain universities in a number of different ways by having to register and go through all of these technology transfer administrative hurdles, and reduce the capacity of researchers across different institutions to collaborate with each other, and essentially change the makeup and the composition of scientific discovery in academia. Now, why did it do that? Because suddenly, instead of just being discoveries in and of themselves, discoveries became business chits, chits that you use for negotiation. And that's really, really difficult, because, suddenly you're not worried about how your discovery is going to affect human beings, but how your discovery is going to affect the market. Now, open science, one of the key priorities of open science has been historically to find ways to circumvent the system of patenting, so that anybody can have access to the scientific discoveries that are made. So essentially the blueprint, let's say, for vaccines can be shared worldwide. The thinking is that by doing so, you can increase the level of access in places that are underfunded or under-resourced, and that cannot compete with the open market. Now, in what we've seen, particularly with the COVID-19 pandemic, is that removing patents, and Akwasi, I'm getting to the heart of your question now after a very long preamble, removing patents isn't enough. Okay, so it is up to governments essentially to control whether other countries can infringe on those patents, and the World Health Organization has been calling for a long time for essentially governments to create waivers so that under-resourced countries, under-resourced settings can have access to these technologies without infringing on patents. So basically, a country like India could just have access to Moderna's blueprint for their vaccine without infringing on their patents and being subject to international regulations and fines. But patents are just one part, we've discovered, of this scientific discovery system. You know, there's the discovery itself, and then there is the entire complex industry around producing these discoveries, like producing actual doses, distributing them, and that's not nothing. And that includes, you know, not only aspects of the vaccine itself that aren't covered by the patent. So in some cases, the shell within which the vaccine is contained is proprietary to companies, but wouldn't necessarily be covered under a patent for a particular vaccine. And then there's the other very complicated aspects of this related to manufacturing capacity. So you need a factory that is established and set up in a certain way that has protocols to make sure that vaccines can be produced that are safe, that are effective, that aren't toxic, that aren't spoiled. And so when we think about open science, it's not enough just to think about patenting. We have to think about the entire supply chain, or sort of the chain of discovery that stretches from scientists working on a particular vexing medical problem all the way to, you know, the way that factories are created and the way that they administer and manufacture, to the ways that to the ways that vaccines are distributed so that they remain unspoiled. And that is a major undertaking. But again, as we're seeing with this pandemic, is that none of us are really safe unless all of us are safe, and that we could see the vaccines become essentially obsolete. And you know, I'm not prone to hyperbole, but that is a chance we're taking with every passing day, that we don't think about, you know, reorienting our system of discovery to make it more equitable so that everybody can have access to them.
Thank you, Dan. And with respect to you know, equitable access, Georgia, in our conversations prior to the session, you'd raised kovacs. I don't know if you want to briefly speak about kovacs and you know, how that relates to what's going on here.
Yeah. So essentially, as you mentioned, open science is kind of like this new wave of innovation. But the problem is that for universities, often innovation just means, you know, creating something, patenting it, and then rendering it unattainable to poorer countries. And so this initiative of kovacs being something where developed countries pledged to provide vaccines to poorer countries, but they failed to do so. I think there were 1.2 billion vaccines, and only 4% went to underprivileged countries. So how can these countries be held accountable? And is it the job of the scientists to ensure that equal distribution of their therapeutic is negotiated with buyers?
Dan, I don't know if you want to tackle that.
I mean, it's a difficult question, and you know, I think one of the things that we need to get away from is this notion of open science versus the for-profit system as a binary. So I mentioned this case of the National Institutes of Health supporting Moderna to create vaccine candidates for pathogens that were not going to make them any money on the market. And so I think that's a good example of sort of a way, you know, one approach to the open science question that essentially changes the balance between the for-profits companies essentially dictating the terms by which they're going to bring drug discoveries or, you know, scientific discoveries to market. You know, there is no world in which I think we can totally just set pharmaceutical companies and biotech companies and other for-profit actors aside and create a parallel system of scientific discovery. But what we can do, I think, is develop a system that sort of pushes back a little bit on the fact that, you know, so much of the work of drug discovery has been ceded to for-profit actors. And that's where I think you know, we want to we want to prevent something like kovacs being needed in the future, right? Kovacs is this system where all these countries are going to donate vaccine doses to lower under-resourced countries. It was, as Georgia mentioned, it was an abject failure because rich countries. I can't remember the exact quote that was in the Lancet when they reported on this last year, but basically, rich countries acted worse than anyone could have ever imagined. Canada early on, instead of donating doses, actually used a loophole to take over 1 million doses out of COVAX so that Canadians would have access to vaccines earlier on. And so, we want to George's point, I think, we want to avoid a situation where we have to have this parallel charitable system that is, kind of an afterthought and essentially a symbolic activity that countries can engage in. And we want to make sure that, we engage pharmaceutical companies, for-profit companies in a system of drug discovery and scientific discovery in which they participate, but in which they may not be leading.
Thanks, Dan, and thanks for that question, Georgia. A good one. And audience members, feel free, please. You have the ability to pose questions as well. So do so, and we'll address your questions towards the end of our session. So Dan, you've just mentioned, Canada manipulating a loophole to basically, I won't say steal back, but take back, steal vaccines, although it's supposed to be given them. What's Canada's approach to open science been? What's our history and approach to open science in this country?
I think that you would assume that a country like Canada, which is all about multilateralism, would be very, very supportive of open science initiatives. But unfortunately, that hasn't been the case. There is a glaring example of the production of an Ebola vaccine that was developed by Canadian scientists and the Canadian in collaboration and through funding from the Canadian government. And it's actually a really dark moment, I would say, in Canadian history. This happened in the 2000s, where this vaccine was developed by Canadian scientists. Canadian scientists wanted to not patent it so that it could be immediately deployed to combat an Ebola epidemic in Africa that was ravaging populations and was extremely, extremely virulent. And instead, Canada decided to patent. They insisted that this vaccine be patented. And then they basically tried to partner with a private company to produce it, rather than sort of generate a vaccine and work with nonprofit actors to manufacture and distribute. What happened, and it's a fascinating story. We almost certainly don't have time to get into it today in all its gory details. But essentially, what happened was they couldn't find a buyer for this patent. They ended up selling the rights for this vaccine to a small startup biotech company in the States that did not have access to the kind of resources required for them to actually, test out this vaccine, to get it rapidly into clinical trials, to manufacture it, to distribute it to people that were being ravaged by this African Ebola epidemic. Mm-hmm. So what happened? This company sat on this vaccine patent for 4 years while people were dying of Ebola, and they just saw it as this business chip, right? Mm-hmm. Eventually, what happened was the Canadian scientists who had initially developed this vaccine were trying desperately to find a partner that could work to manufacture and produce it. And I believe it was Merck ultimately, and apologies for those in the audience who know better, but if I've gotten that wrong. But I believe it was Merck that ultimately ended up purchasing the patent from this small company, developing and distributing this vaccine. But it was all the result, this delay. And of course, this company made tens of millions of dollars just sitting on this patent. And this was all a result, the delays were the result of the Canadian government making a decision to patent a vaccine that they had worked on with scientists working in academia, despite opposition and criticism from those scientists themselves. More recently, I think this was last year, or maybe at the close of 2020, the Canadian government released this framework for a path to open science in Canada. It appears to be sort of moving towards this notion of trying to support research and scientific discoveries for the public good. Whether that's actually going to turn into something, I don't know. I think that it appears that the government is more interested in partnering with pharmaceutical companies and developing manufacturing capability than it is in really supporting and generating an open science pathway to scientific discovery.
So much, I'm going to say locked behind paywalls. I'm thinking about myself as a social scientist, right? I don't, necessarily discover things that are going to cure coronaviruses, but as social scientists, we engage in work, we publish our work in journals, and then those journals are unfortunately, inaccessible to the public unless they're willing to pay thousands of dollars to get access to them. And so this is, this problem that you're speaking of and that you write about is something that really spans knowledge production, right? It's certainly not limited to this specific area. I want to talk a little bit about misinformation in a moment, but before we do, what can we do to ameliorate some of the problems that you're discussing? What can we do to kickstart an open science model for medical discoveries?
Well, I think that there needs to be a reorientation of the relationship between academia and for-profit systems, and that starts with government. You can't generate a system that doesn't rely that eschews patents if there isn't some kind of form of public funding. It also requires buy-in from universities. And I think, Georgia, you really hit the nail on the head here, that universities have been caught up in this drive towards innovation. The irony being that innovation just means money. It just means selling discoveries, making and then by doing so pricing them too high for markets where they won't be afforded, and ultimately just amplifying and replicating systems of inequity that we're experiencing. So I think there needs to be this openness to open science, to essentially coin a terrible phrase, but an openness to open science on the part of academia, to not require that every discovery that an academic makes needs to be patented, right? And I think that, and then on the flip side, there needs to be support for that and kind of a pathway laid out through policy and through funding by governments so that you can understand. I think there's so many scientists working out there that do not focus on the complexities of getting their discoveries to market, right? They're focused on the actual work of making those discoveries. So you need to lay out, what is an alternate pathway by which scientists can get their discoveries out there and demonstrate the incentives for doing so that, go far beyond what is possible in the for-profit system, which is essentially making sure that they're accessible to millions of people who would otherwise not have them. I think that's a really important part. And then the other part, and I sort of touched on this before, is finding a new way to balance the role of pharmaceutical and other for-profit entities. Again, we can't just simply set up a separate system of scientific discovery that doesn't involve for-profit actors. Like we're too far down that road. But what we can do is think about how do we want to partner with for-profit actors. And I will say that the pandemic has revealed a lot of appetite on the part of pharmaceutical companies to engage in these collaborative networks in which they see value in funding scientific networks and networks that focus on scientific discovery that are working on problems that are not immediately marketable, but maybe in the future. So for example, there's the Structural Genomics Consortium, which is run out of the University of Toronto. It's got like over $100 million in funding from a range of pharmaceutical companies. And it's taken that money and working on this really early stage sort of drug development work that is completely not patented. None of that work is patented. It's all publicly available. And that is a key component of the Structural Genomics Consortium. And all of that public knowledge benefits all of the pharmaceutical companies that are investing in it. They don't require that those discoveries are patented. And so finding these creative models, I think, to generate interest from for-profit actors, like it's not impossible. You just have to be a little clever about it.
Creative, undoubtedly. Speaking of creative, people have been creative with the information that they've been sharing, both about the virus and the vaccines. Georgia, I don't know if you want to, talk about some of the observations that you have just generally and that come from the book with respect to misinformation.
Yeah, of course. There's so much of that going around these days, and I feel as though COVID-19 really kickstarted that. So we were talking about how important governments are in open science, and governments are also really important in forming public perception and opinions. So I wanted to touch a little bit on how misinformation that's relayed to the public by government officials is quite dangerous, as we saw with President Trump. And so it really just risks a lot of the hard work that scientists are doing and have done to protect the public. So I'm wondering, how can we bring science to the forefront of the news in an understandable and helpful way?
That's a great question. And I think it starts with, hindsight is always 2020. I think it starts with an acknowledgement of the limits of scientific discovery, right? And the limits of science as a system. So the beauty of science is not that it has all of the answers all of the time. It is that it is self-correcting, right? That when there are errors, those errors will almost always, particularly the greater the error, the more confidence we can have that it will be corrected within this system, right? And that's basically the scientific method. So rather than thinking about, science as a monolithic system of knowledge that provides us answers in the moment, we should be describing it as this system that evolves, and the evolution of that system as new facts are discovered, as new events occur. Like, that is where the confidence, I think, should lie. So that's number one. The second is that, and there's always a shorthand in the media where scientific discoveries are framed as sort of like, this vaccine is 95% efficacious, right? It's exactly that efficacious. When in point of fact, all of these scientific discoveries and all of the scientific research that happens is about generating bounds of confidence, right? So oftentimes we talk about confidence intervals. It's a statistical term describing how reliable or how, the range of potential values that an outcome might lie within. And starting to talk about those range of values rather than, a single, hard number, I think it's a more difficult conversation. It's harder to convey to the general population. And maybe I'm sounding a little dorky saying that we should be talking about confidence intervals more often in newspaper articles. But I think describing the fact that, an outcome or say a vaccine's efficacy or the projections of mortality are actually within a defined range, I think again, it's a little bit harder for people to engage with, I think, initially, but it also, I think, demonstrates for people over time that, we actually have control over, in the case of, projections, that we actually have control over how many cases there are that occur. And in the case of vaccines, if people are saying, oh, well, you said it was 95% efficacious, and actually we're looking at the data and it appears to be much less than that in this particular situation, you're not bound to those initial claims that, about, oh, it's exactly this efficacious, it's exactly this effective, we're going to have exactly this number of people saved if everybody wears a mask. I think basically seeding our conversations about scientific outcomes with the doubt with which scientists talk about them could go a long way in sort of reducing the kind of wariness around scientific information that people experience.
Yeah, thank you for that. And it seems like the ways in which that is communicated to the public is really important. So distilling those facts, really, and also providing information that this might change, and that's the scientific method. So providing this scientific literacy seems to be the way to go.
Yeah, I mean, you think about the mask issue in particular, right? So this conversation is obviously very, very active in Canada. We saw the Freedom Convoy and, major controversy and antagonism around the kind of public health restrictions that were in place. And one of the criticisms around masks in particular is like, oh, when this pandemic started, you said that masks weren't effective. I mean, yeah, it's true. But knowledge is gained, data emerge, and the understanding of what is and is not effective evolves as well. So, I think there will be a lot of lessons learned in the way that scientific data and evidence is communicated, or I hope it is communicated to the public, given all of the ways in which I think public health authorities painted themselves into a corner with these claims about, effective and ineffective ways to manage this virus, because it just constantly kept shifting, right? The virus shifts, our relationship with the virus shifts, our restrictions shift. It's not a steady, static experience being in a pandemic, even though it feels like that for so many of us.
So I want to ask a related question then that I'm sure will be of value to our viewers. You're trained as an epidemiologist, but as I know well from our collaborations, much of your recent work has focused on substance use and on drug policy. So, in thinking about facts and in thinking about truths, can you talk a little bit about the process of writing the book and how you found and engaged with the material you did in order to provide such a comprehensive and engaging overview of, the rise of coronaviruses and the, related to the conversation we've been having about the vaccines?
Yeah, absolutely. And it's a question I've gotten quite a number of times from people who know my work, which, as you say, is mostly focused in terms of my academic work on substance use epidemiology. I will say there's something liberating about writing, for a general audience, writing something that's supposed to be gripping, that is narrative driven, that is character driven, about a topic that you know little about going in. I think that in a way I was, I essentially, you can take the handcuffs off a little bit when you're writing about something that is outside of your area of expertise. I know that sounds counterintuitive, but you're a little bit liberated by doing that. And I think also writing about a subject that you are not expert in allows you sort of this interesting vantage point where you can sort of act in the reader's place a little bit more. And you're not as blinded to the kind of siloing of knowledge and assumptions about what people do and do not know about this area of science that may be present when you're writing about the work that you yourself do. So, for me, it was a really interesting it was a really interesting process because I went in knowing zero about coronaviruses and very, very little about, the structural biology of viruses or the work of kind of basic science testing of like gain of function research and undertaken with viruses or vaccines or anything like that. So I would have these conversations with these virologists and they would be talking a mile a minute. And it was like speaking with someone who was speaking a different language, like truly. It's like I know about 20 words in Spanish. So sort of like talking with someone who is speaking Spanish and I'm trying to pull out the few words that I know. And then going through after the interviews, after they've been transcribed, going through those transcriptions and then diving into the scientific literature to understand basically what they were saying to me. And as I did that, over the course of, I don't know how many, I'd probably, at least 100 interviews with scientists and other people involved in this work, you start learning the language a little bit. And between the interviews and pulling out the scientific research, I became, I saw my job basically as a translator, right? I was taking this knowledge that is, as you say so often, even when it's open access, it's really, really difficult for us to understand. And taking and distilling down what was essential about it and what was fascinating and thrilling about it and writing about that for a general audience. And frankly, I don't think I could have done that had it been my area of expertise, because I would make all these assumptions about what a reader might already know, which I certainly didn't write in this book because I started out knowing basically nothing.
That's fascinating. I'll say that your lack of knowledge going into the process was not evident in the final product. So kudos for that. We've got some questions that have come in from the audience I'd like to address. One from a viewer named Taxworthy. Do we need a publicly owned drug company in Canada as we had with the Connaught Labs? What are your thoughts on that?
Yeah, that's a great question. And, the Connaught Labs, for those that don't know, it's a really interesting history. This was a lab that helped develop some of the earlier vaccines in the first half of the 20th century and sort of mid 20th century in Canada and Toronto. It was sort of this estate affiliated with the University of Toronto. And ultimately, I believe it was sold to Sanofi, if I'm not mistaken, but it may have been another pharmaceutical company. I've heard different opinions on this. I honestly don't feel totally equipped to answer it based on just my own opinion, but I've heard opinions from people working in open science and in vaccine development that Connaught Labs as a model is out of date, right? So it's not necessary that we invest in something like a standalone lab that will develop vaccines, but that instead we think about, okay, well, how can we create an ecosystem of actors that engage in open science discovery that involves sort of those range of actors that I talked about before, right? So academia, government, potentially other funders like, private foundations like the Bill and Melinda Gates Foundation, as well as for-profit actors that are hooked into the system that do not dictate whether, the work is going to be patented or not, but that see some value in it, and respect the fact that an open science approach to medical discoveries is still going to yield them some benefit. So I think it's like we need a Connaught Lab 2.0, or if that's not too cheesy, but a way that sort of breaks down this sense of a unitary laboratory, a lone laboratory that's developing work, and think about an ecosystem of actors that collaborates together towards an open science goal.
Thank you, Dan. And another audience question, and this is going back to something you'd said about the Canadian company sitting on the patent for the Ebola virus vaccine. So how did the company make money sitting on the patent? You'd mentioned there was I think it was a 4-year period of time.
They just waited, essentially. I mean, they had this business chit, and there were actors that were interested in getting a vaccine to market, right? And those actors were the Canadian scientists who originally developed the vaccine, the Canadian government, and a pharmaceutical company that was acting essentially as an ethical broker, right? Like, I believe it was Merck, and I'm sorry, my brain is slightly fried today, but I believe it was Merck that essentially, was convinced or decided to engage in this issue of trying to get a vaccine that had been developed to a setting in Africa where there was this Ebola epidemic. And, this small company that bought it in the US, like they just waited until there were offers. They didn't have to do anything. And all they had to do was just sit on it. They had made a small investment to purchase the patent. If they never made money on it, I don't think it would have been, they didn't have a ton of skin in the game. They certainly weren't going to do anything with it themselves because they didn't even register a clinical trial for years. And they didn't have the resources to even mount one. But, they just read the market. They made a bet, and ultimately there was enough interest in getting this vaccine to market, again, to a market that wouldn't have, wasn't competitive in sort of like a free market sense. But, they just waited around. It's a really shocking story.
I'm looking at the time, Dan. We're about to close things off. I want to ask one last question. Have there been any developments since you submitted the book, or anything that didn't make it into the book that you'd like to share with us?
Yeah, so, this book is really character driven, and one of the protagonists is this incredible coronavirologist named Ralph Baric, who, if you go on Twitter in the darker areas of on the darker areas of internet, you might see being accused of, all kinds of conspiracy theories about generating this virus. Anyway, I'll leave it up to you to go down that road. It's certainly disgusting. But one of the things that Ralph Baric has done is he had been studying and still is studying coronaviruses, and has been doing so since the early 1980s. And more recently, this is someone who helped test the efficacy and safety of Moderna's vaccine. He helped bring remdesivir to market. He helped bring molnupiravir to market. He's basically, he's one of the first people to isolate the spike protein and understand how it functions and why it's important for cellular replication and entry into, or viral replication and entry into cells. And there's, the reason that there is the spike protein in all of these vaccines is, largely a result of Ralph Baric's work. And more recently, what he's been doing is developing a pan-coronavirus vaccine. So he's thinking ahead again about, we've seen now 3 coronaviruses, pathogenic coronaviruses, emerge into human populations in 20 years. So now we've got a trend. There is almost certainly going to be another one. So how do we protect ourselves? And the way he's doing that is he's thinking about, okay, well, let's create a vaccine that has a number of different mRNA strands in it, all programmed to different types of spike proteins found across the coronavirus family. And by doing that, we can have a vaccine that's ready and at least partially effective, if not very effective, against whatever coronavirus shows up next. So it's a really incredible and again, really prescient approach to trying to protect ourselves from the next pandemic.
Dan, Georgia, thank you for this stimulating discussion. For those of you out there that haven't read the book yet, The Invisible Siege, The Rise of Coronaviruses and the Search for a Cure, I recommend getting it to put on your bookshelf, downloading it to have on your phone. Thank you again. I hope you all have a nice rest of your day.
Thanks so much.
Thank you.